Hello, and thank you for having me here. As Barb said, I'm here to tell you a little bit about the waste classification systems of the Nuclear Regulatory Commission and the Department of Energy. And what we're going to do is we're going to go over the authority of why we have two different systems in the United States. Then I'll walk you through, and I don't know if you can see that little red dot, but I'll walk you through the NRC classifications and then the DoE classifications, tell you why the systems are different. Then we'll go over some general waste types, and we'll spend a little bit of time on spent nuclear fuel. So I want to remind everybody that we are talking about radioactive waste. So it has a radioactive component. We're discarding it. It has no programmatic use. But we're not talking only of Department of Energy. We're talking commercial reactors, hospitals, any place that generates or disposes of radioactive waste. So the history of the authority. The Atomic Energy Act of 1954, as amended, is the fundamental law for all things nuclear material. For civilian and military use of nuclear materials, it established the Atomic Energy Commission in 1954, and they regulated all nuclear materials. Then in 1974, the Energy Reorganization Act was passed by Congress, which split the Atomic Energy Commission into two entities, the Nuclear Regulatory Commission and the Energy Research and Development Administration, which 3 years later became the Department of Energy. The NRC, the Nuclear Regulatory Commission, and I'll tend to use the acronym. So they regulate the commercial and other federal agencies other than the DOE. And then the Department of Energy regulates the military and research development for nuclear materials. So that's how they split out the responsibilities in '74. Then in 1982, the Nuclear Waste Policy Act was passed. This assigned roles and responsibilities for high-level waste. Then the Low-Level Radioactive Waste Policy Amendments Act of 1985 set up the state compact system, where states were given the responsibility for disposing of radioactive waste that was generated within their state, but they could combine with other states into compacts and have regional disposal facilities. The whole idea was to site, design, and build regional facilities. And then the Energy Policy Act of 2005 added some regulatory authority for the NRC for radioactive materials that have bad actors. And it gave them more regulatory authority over those. And it also assigned the Department of Energy the responsibility for greater than Class C waste, which we'll get into on what that is in a little bit. So just to give you an idea of how these amendments change the roles and responsibilities. So we have high-level waste, which is in green, because it's a combination of NRC and DOE. So yellow and blue make green. DOE is responsible for the disposal facility. The EPA is responsible for establishing the standards for that. And the NRC is responsible for licensing that facility. We'll get into what these waste types and waste classes are, but for right now, this is to give you an idea of the responsibilities. DOE is a self-regulating authority, but we play with others. There are other responsibilities for the waste that we generate. So for greater than Class C, which is an NRC class, DOE is now responsible for the disposal facility. NRC is going to license it. For transuranic waste, which is a DOE definition, DOE is responsible for the disposal. This is the waste isolation pilot plant in Carlsbad, New Mexico. EPA has certified that, and the state of New Mexico has issued a permit. For low-level waste, DOE low-level waste, DOE is responsible for disposal, and if it is mixed waste, of course, we have a permit from the state. Class A, B, and C is the NRC definitions. These are agreement state licenses of commercial disposal facilities, and we'll get into what an agreement state is in the next slide. Excuse me. And for this, so greater than Class C and transuranic are generally not near surface disposal, where the low-level waste classes are. So for implementation, DOE uses the DOE directive system. We have an order called 435.1, Radioactive Waste Management. It is for the generation, treatment, storage, and disposal of all radioactive waste. It comes with, the order has the roles and responsibilities and authorities. The manual has all the requirements, and then it has 2 guidance documents to help you implement those requirements, the guide and this technical standard, disposal authorization statement, and tank closure documentation. So DOE has 3 classes of waste: high-level waste, transuranic waste, and low-level waste. So 3. The NRC has the Title 10 Code of Federal Regulations, Parts 1 through 199, and/or state implemented programs. The state implemented programs, the NRC can delegate their licensing authority to an agreement state if the state has the programs in place that they approve of. And so 37 states are agreement states under the NRC. But for this presentation, I'll be saying NRC regulations and not differentiating between the states. They have, whoops, wrong button, high-level waste, and then they have Class A, B, C, and greater than Class C. And we'll get into that. There is not a one-to-one correlation, except for high-level waste. The definitions are different for the different classes. So the NRC low-level waste classification, and this is only the low-level waste classifications. We'll get into high-level a little bit later. So it is codified in 10 CFR 61.55 waste classification, and it is based on 3 things: the waste characteristics, long-lived radionuclides, and short-lived radionuclides. And those are almost 3 steps that you have to do. The classes, again, are A, B, C, and greater than Class C. And as you go up in class, Class A being the lowest, there are more rigorous controls and regulations as you go up in class. So, for waste characteristics, you have a handout. I believe it's green. Both DOE and the NRC have low-level waste characteristic requirements. The DOE has 5 physical, chemical, and stability requirements. NRC has 8 physical and 3 stability. But if you look at them, and these are the regulations right out of the DOE manual and the NRC regulations. If you look at them, they're very equivalent, and you can read them at your leisure looking at this thing. But if you look at DOE number 3, where waste can't be readily capable of detonation or explosive, and then it goes on, pyrophoric materials have to be stabilized. And then you look at the NRC number 4 and 6, you'll see that they're almost exactly the same. So there is a lot of similarities between these regulations. And you'll notice that for DOE, we don't have an equivalent for 1A or 1.8. 1A is a container requirement. We do those in our waste acceptance criteria. Rob's waste acceptance criteria for Area 5 has container requirements. And then A8 has to do with infectious waste and biological waste, and those are very dependent. Again, we take care of those in the waste acceptance criteria. So both systems have these requirements. Now, if you have a waste that is a liquid, and you go to these, the first thing you do is look at these characteristics, you're not allowed liquids. You'll notice in DOE, it's number 2, NRC, it's number 3. So you will have to process your waste before it can go to disposal. So Class A waste is the lowest class. It's 96% of the low-level waste in the commercial facilities. It usually decays within decades. Class A does not have to meet the stability requirements in the NRC regulations, but if they don't, then they're generally segregated from other waste classes. Class B decays within a few decades, and it requires shielding during transport. Class C, again, is the highest amount that they're allowing for shallow land burial, and it takes hundreds of years to decay. Greater than Class C, that is their highest level of low-level waste. And it may or may not be appropriate for shallow land burial, and we'll get into a little bit of that a little later. So, you've looked at your characteristics, you've discovered whether or not you need to process it to meet those stability and physical and chemical things. Now you look at the radionuclides within your waste stream. So, if I have a waste stream and you start with the long-lived radionuclides, that's table 1, and the bottom one is table 2. And we've put them together to help you walk through this. So if I have a waste stream with nickel 59, which is right there, and I have less than 22 curies per cubic meter, it drops out. And if I have something other than nickel 63 in my waste stream, I have to go to table 2. But if I only have, nickel 59, and it's less than 22, it is Class A. If I have between 22 and 220, it's Class C. If I have more than 220, it's greater than Class C. So that is for the long-lived radionuclides. Say I don't have any long-lived, I only have short. So you go down to table 2, and say I have nickel 63, if I have less, and they have 3 columns in table 2. If I have less than the amount in column 1, so I have less than 3.5, it's Class A. If I have between 3.5 and 70, it's Class B. If I have more than 70 but less than 700, I have Class C. And if greater than 700, I have greater than Class C. If your radionuclides are not on either table, you default to Class A. If you have a mixture, you do something that's called a sum of fractions. It takes a lot of math, and I'm not going to get into it at this point. But you use these tables with the math, the sum of fractions, and you figure out where your waste falls out. So DoE classification. Our classification system is codified within our DOE manual 435.1-1. And we classify waste by source and concentration. High-level waste is classified by its, or defined by its source. Transuranic waste is defined by a concentration. And low-level waste is defined by what it is not. And I'm sure you've heard that before. So high-level waste. I'm going to read this definition because it's very complex and very long. So, highly radioactive material resulting from the reprocessing of spent nuclear fuel, including liquid waste produced directly in reprocessing, and any solid material derived from such liquid waste that contains fission products in sufficient concentrations, and other highly radioactive material that the Commission, consistent with existing law, determines by rule requires permanent isolation. Anybody know what that means? Because I don't. So I have added the emphasis on highly radioactive material and sufficient concentrations. So just keep that in your mind for a minute. So commercial reprocessing stopped in 1977, and DOE stopped reprocessing in 1992. DOE sites in Washington, South Carolina, and Idaho have high-level waste. But high-level waste will eventually have to comply with the waste acceptance product specification for vitrified waste, or the system requirements document for non-vitrified immobilized low-level waste. Until there is a repository somewhere, these documents give you almost an equivalent of a WAC, because we don't know what the WAC is going to look like, the waste acceptance criteria. So high-level waste has to meet those two, or one of those two. Now, in June of last year, DOE put out a high-level waste interpretation. The highly radioactive material and the sufficient concentrations were never defined. So DOE is now interpreting the statutes to provide that a reprocessing waste may be determined to be non-high-level waste if the waste meets either of the following two criteria. So they're defining what those are. So if it does not exceed the concentration limits for Class C, so we're taking the NRC definition of Class C and anything Class C and less, and it meets the performance objectives of a disposal facility, which to me means it meets its waste acceptance criteria, then it is not high-level waste. Or if it doesn't require deep geologic repository or disposal in a deep geologic repository and meets the performance objectives of the disposal facility as demonstrated by a very specific performance assessment, then it might not be high-level waste. So this is new. It has not been implemented. The first thing that has to happen before it is implemented is a NEPA, or a National Environmental Policy Act process. They have started that on a waste stream in Savannah River. If you would like, the draft environmental assessment for the commercial disposal of defense waste processing facility, recycle wastewater from the Savannah River site, the comment period has been extended till the 20th of February. So this is ongoing. They have not finished it. But if you'd like more information on this interpretation, there's a link here to the EM website. So for transuranic waste, this is a concentration-based standard. You have to have 100 nanocuries of alpha-emitting true isotopes per gram of waste with half-life greater than 20 years. There are 3 exceptions to this definition. It can't be high-level waste. The waste that DOE and EPA agree does not need the degree of isolation. So again, there's something in it that doesn't need to be in a deep geologic. Or waste that the NRC has approved. This gives the NRC a case-by-case approval. So what is a true isotope? It's an atomic number greater than 92, 92 being uranium. So transuranic is above uranium, and which includes neptunium, plutonium, americium, and curium. And for true waste to go to WIPP, it of course has to meet their waste acceptance criteria. So low-level waste is what it is not. This is not high-level waste. It's not spent nuclear fuel. It's not transuranic waste. It's not byproduct material, and it's not naturally occurring radioactive material. Now, we haven't really talked about those last two. We don't do a whole lot with them, but they are not low-level waste unless DOE decides to manage them as low-level waste. There's a little bit of an option on those two. Examples of low-level waste, of course, are the soil that you dug up in Tonopah, the PPE that you get from other sites. Low-level waste can take any form or shape. That doesn't mean that it's not highly radioactive. Again, it's not concentration-based, and it's not high-level waste. It's everything else. And it can be hazardous, but wherever it's going, it has to meet that site-specific waste acceptance criteria, whether it is a commercial facility or a DOE facility. And so this is the DOE classification in a graphic form. You have radioactive waste. Is it from reprocessing of spent nuclear fuel? If it's yes, then it could be high-level waste. If it's no, you look to see if you have transuranic isotopes with half-lives greater than 20 years, greater than 100 nanocuries. If yes, then it's true waste. If no, you look to see if it's 11E2 byproduct or norm. Those can be not managed as low-level waste, which are generally tailings. Or if it's not any of those three, it's low-level waste. So now we're going to go into why these are different. How did they evolve? And we'll go to NRC first, then DOE, and then I'll show you some of the similarities. So why are they different? So the NRC and the states regulate the commercial reactors, the radiological laboratories, the medical entities, anything out in the commercial world, including other federal agencies that have radioactive materials. They issue licenses. DOE regulates the development and production of nuclear weapons and research. Both of the systems are based on performance objectives, which are quantitative radiological standards for the protection of workers, the public, and the environment. They're based on International Commission of Radiological Protection recommendations, and right now we're going to be talking about shallow land burial. So the main goals for both systems, of course, is the protection of the general population and the environment, protection of individuals from inadvertent intrusion, which means you're digging up waste but you didn't know waste was there. Protection of individuals during operations. We want to protect our workers when they're dealing with this waste. And the stability of the disposal site after closure. We don't want things happening after we close them. So the NRC basis. Remember the compact system, where we thought we were going to have a whole bunch of individual regional disposal facilities? So when they were developing their regulations, they didn't know where those facilities or locations were going to be. So they came up with a performance assessment for a generic disposal facility in various locations, including inadvertent intrusion. And they came up with those stability requirements and the two tables for the class A, B, C, and greater than class C. So they're very specific on the quantitative concentration limits, and they're based on very well-known waste streams. And we'll get to that in the next slide. But facilities, for disposal facilities, are then licensed for A, B, C. There's currently no licensed facility for greater than class C. So examples of the waste streams that they used in this generic performance assessment is hospital waste. Now, you may have millions of hospitals, but they only use certain specific radionuclides, and the waste is not going to be that different from hospital to hospital. So it's a very well-known characteristics. Again, with the nuclear reactors, you may have slight design differences, but their waste streams are going to be primarily the same. The waste streams for nuclear reactors is dry waste, which is paper and plastic, wet waste, which is resins, and irradiated hardware. And if you look at these waste streams, these tend to be A, these B, and these C. So class A, B, and C. So when they were developing the regulations, there were 3 operating low-level waste disposal facilities. Beatty, Richland, Washington, and Barnwell, South Carolina. Right now, the only existing ones are Richland, Washington, Barnwell, South Carolina, Clive, Utah, and Andrews, Texas. So U.S. Ecology, Energy Solutions, and Waste Control Specialists. For DOE, we knew where our disposal facilities were. The DOE complex has been pretty well set for a while. We don't have new locations coming on board. So we went a site-specific performance assessment. We already were disposing of waste. So we came up with site-specific conditions within our performance assessments and came up with the waste acceptance criteria for the facilities. The performance assessments drive the radiological limits in your facility. And that way you get your permissible levels. And our waste streams were not well defined. They're various, they're complex. We're making up, well, we're not making up, we're discovering new elements. Sorry. We were doing plutonium production for a long time. We were enriching uranium. We were D&D buildings. A lot of stuff that the commercial facilities aren't doing. We're doing R&D. And that makes our waste streams more complex. So, graphically, the NRC took well-defined waste streams from commercial industries, did a generic performance assessment and came up with their classes, and then their disposal facility, based on characteristics, gets licensed for whatever class they can then take. DOE, we already had our facilities. We did a performance assessment, came up with what radionuclides and what levels the facility could take, put it in our waste acceptance criteria, and then those waste streams have to meet that to go to our facilities. So if you look at the manual and the NRC, and Part 61 is their part for disposal facilities. They are very, very similar. I'm not going to read these slides to you. There's a lot of text. But if you look at them, there's a lot of similarities. You have to have a license. For us, we have to have a disposal authorization statement from headquarters, same as a license. So you can look at these at your leisure, but there are a lot of comparisons. So this is a map of both DOE on-site and commercial options. So if you see U.S. Ecology up here in Washington, they can accept A, B, and C waste from the Northwest and Rocky Mountain compacts only. So they only accept waste from those states that are in those compacts. Energy Solutions here in Utah only accepts Class A waste. They're only licensed for Class A. And then Waste Control Specialists in Texas can take A, B, and C. And Barnwell in South Carolina can take A, B, and C, but from the Atlantic Compact only. So there's only 2 commercial disposal facilities that can take waste from any state. The others are restricted to the compacts. For DOE, we have Hanford, Idaho, Nevada, Los Alamos, Oak Ridge, Savannah River, and Portsmouth is building one. We have closed Weldon Springs and Fernald. Nevada takes off-site waste, and you'll see these tank farms, again in Hanford, Idaho, and Savannah River. Those are the high-level waste. Then we're going to go on to certain waste types. So we've got the classes. We've got 2 different systems, but we also have other regulations, like the Resource Conservation and Recovery Act, which is RCRA, which makes mixed waste. And mixed waste is radioactive waste with a hazardous component that is regulated under that regulation, under RCRA. So like chromium, lead, mercury, under RCRA there are certain levels that make waste hazardous. So if your waste stream has more than 5 parts per million of lead, it is hazardous under RCRA. It's considered a mixed waste if you have a radioactive component, and you have to comply with the EPA regulations of 40 CFR 262-280, along with either your commercial or DOE regulations for the radioactive component. And high-level waste, unless it's demonstrated otherwise, is considered mixed waste. For Toxic Substance Control Act waste, which is polychlorinated biphenyls, PCBs, and asbestos, generally these are the 2 substances that are regulated under TSCA. We don't call it mixed waste, it's a TSCA waste, but they're managed under 40 CFR 761 and 40 CFR 62. They have storage, treatment, and packaging requirements that get incorporated into the WAC that you must meet if the disposal facility can take TSCA waste. And you may have additional state requirements if the state regulations are stricter than the federal. For radioactive classified waste, this is radioactive waste which has access limited for national security reasons and cannot be sanitized or demilitarized. And it's regulated under DOE orders, NNSA policy letters, and the disposal facilities have to go through quite a bit to get designated as a classified waste disposal facility. So we're going to spend a little bit of time on spent nuclear fuel, not a lot. Spent nuclear fuel has been withdrawn from a nuclear reactor following irradiation, and it has not been reprocessed. That is spent nuclear fuel. Now, DOE considers it material and storage. They consider it an asset. They do not consider it waste. The NRC considers it high-level waste. So on the commercial side, it's high-level waste. On the DOE side, it's an asset, because remember, we still do research and development on spent nuclear fuel. But there is a division within DOE that does that. So the order 435.1 does not apply to spent nuclear fuel. But DOE is responsible for the disposal site, and NRC, of course, will license that disposal site. So in review, we went over the authority of why we have two different systems. We went over the NRC system, the DOE system. We looked at why the systems are different and how they were based and how they evolved. And then we went through some waste types and spent nuclear fuel. So the key messages is, of course, the low-level waste NRC classification system was generic because they didn't know where it was going to go, but they had well-defined characteristics in their waste. DOE, we knew where it was going to go, but the varied waste streams, because of the R&D, made it for site-specific conditions. They have different bases, but they're both for the protection of workers, the public, and the environment. And there's a lot of similarities between the regulations. These are some references if you want to have a little bit more information. This report, it's a little dated. It's in '06, so it doesn't have the high-level waste interpretation. But if you want a very good summary of all of this, it's a very good resource. I gave you the order and the NRC regulations. The International Atomic Energy also has guidance out on classification of waste streams for other countries. And then this is a United Kingdom document that has international approaches to radioactive waste classification, and they do go into the U.S. systems. And that's it. Any questions? No? Jared, did you find it?
So on slide 13, it's DOE classification system.
Okay.
I'll wait for you to get there.
There.
Just the start of it. So it says high-level waste is defined by its source. So my question was, like, if you had the same type of waste but different sources, could one be considered high level and one be low level, but it's the exact same waste?
High-level waste comes from the reprocessing of spent nuclear fuel. So if the waste is coming not from that reprocessing, it's not going to be high-level waste.
Okay, got it. Thank you.
But the liquid waste that comes out of the reprocessing, I can't think of any other process that's going to generate anything like that.
Okay.
So, anything else? Okay, well, thank you very much for your time, and I hope you found it informative. And we're early.